This is SpaceTime Series 21, Episode 89. Coming up on SpaceTime, NASA's OSIRIS-REx spacecraft gets its first images, Trojan dust clouds confirmed in Earth's orbit around the Sun, and the launch of a new climate change satellite. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
After 2 years of travelling through space, NASA's OSIRIS-REx spacecraft has taken its first images of its mission target, the asteroid Bennu. The new images will act as calibration tools for more detailed images to be taken next month using colour filters. OSIRIS-REx was launched back on September the 8th, 2016, on a 2-year journey to the primitive diamond-shaped asteroid Bennu, arriving last month. These first images have been obtained using Polycam, one of 3 cameras aboard the spacecraft. They were taken at a distance of 330 kilometres above the asteroid's surface. During the bare minute elapsed time between the first and last of the 8 exposures, the asteroid rotated some 1.2 degrees. The team used a super high-resolution algorithm to combine the 8 images, producing a higher-resolution view of the asteroid. These first images capturing the entire asteroid are used for an important number of calibrations that are fundamental to correctly interpreting the results obtained from higher-resolution images using different colour filters. In December, scientists will start to obtain images using the MapCam camera. That uses colour filters to allow researchers to generate maps studying the geographical distribution of different minerals on Bennu, including silicates altered by the presence of liquid water. These studies will also help to select a region on the asteroid's surface where samples can be collected for return back to Earth in 2023. 101955 Bennu is a carbonaceous Apollo group asteroid, meaning it's a near or near-Earth object with an orbit that intersects with and crosses Earth's orbit around the Sun. Bennu is classified as a B-type carbonaceous asteroid, generally similar to C-type carbon asteroids, but with surface spectra suggesting anhydrous silicates, hydrated clay minerals, organic polymers, magnetite, and sulfides. The 492-metre-wide space rock currently has one of the highest known chances of hitting the Earth, with a 1 in 2,700 chance of impacting our planet between 2175 and 2199. On average, an asteroid the size of Bennu can expect to crash into Earth roughly once every 130,000 years or so. If Bennu were to hit the Earth, the resulting impact would be equivalent to 1,200 megatons of TNT. Bennu's orbit is intrinsically dynamically unstable. Dynamical studies have predicted a series of 8 potential Earth impacts by Bennu between 2169 and 2199, none exceeding a 0.071% chance of impact. Bennu will pass 750,000 kilometres above the Earth on the 23rd of September 2060. And that close approach is crucial because it will affect the next close encounter on September the 25th, 2135. That's expected to be at around 300,000 kilometres, although it could be as close as 100,000. Now, there's no chance of an Earth impact in 2135. But depending on how the asteroid's affected by that close encounter with Earth, future encounters with our planet start to get really interesting. That's because the asteroid could pass through this 55-kilometre wide, well, it's a sort of gravitational keyhole, and that could create an impact scenario in a future encounter. On the 25th of September 2175, there's a 1 in 24,000 chance of an impact with Earth. But the nominal 2175 approach will be in February at a distance of roughly 15 million kilometres. The most threatening chance of impact will be on the 24th of September 2196, when there's a 1 in 11,000 chance of Bennu slamming into the Earth. All in all, that adds up to a cumulative 1 in 2,700 chance of an Earth impact between 2175 and 2199. Launched from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket on September the 8th, 2016, the 2,110-kilogram OSIRIS-REx spacecraft is spending 3 years orbiting the asteroid Bennu, mapping the space rock's surface and geology, studying its evolution, composition, chemistry, and mineralogy. One of the mission's key objectives will involve understanding non-gravitational influences on the asteroid, such as the Yarkovsky effect, in which sunlight heats up the surface of an asteroid. and that heat is then radiated back into space as the asteroid rotates, in the process providing a small amount of thrust. So, knowing Bennu's physical properties will be crucial for scientists trying to determine the likelihood of this mountain-sized asteroid slamming into the Earth. In July 2020, OSIRIS-REx will fly down and hover just above Bennu's surface, extending a robotic arm to collect up to 2 kilograms of pristine asteroid regolith for sample return to Earth. The spacecraft is slated to leave orbit around Bennu in March 2021, with the sample return capsule then being jettisoned for a parachute landing in the Utah desert in September 2023. You're listening to SpaceTime. I'm Stuart Gary. Astronomers have confirmed 2 elusive Trojan-like dust clouds which are in Earth's orbit around the Sun. The clouds are in the Lagrangian L4 and L5 positions. Lagrangian points are positions in space where the gravitational pull of 2 bodies, such as the Sun and the Earth or the Earth and the Moon, tend to cancel each other out, while at the same time equalizing the centripetal force needed for a small object to move in unison with the 2 larger bodies, and so allowing a small object to remain in that position relative to the 2 larger bodies for extended periods of time. In all, there are 5 Lagrangian points, known as L1, 2, 3, 4, and 5. L1, 2, and 3 are all along a line connecting 2 bodies, say the Earth and the Sun. Now, in such a case, L1 is between the Earth and the Sun, and is often used by spacecraft to provide uninterrupted views of the Sun, one case in point being the Solar and Heliospheric Observatory satellite SOHO. The L2 position is on the opposite side of the Earth from the Sun. It's home to the Planck spacecraft and the soon-to-be-launched James Webb Space Telescope. That's because it's an ideal position for astronomy, as spacecraft are still close enough to communicate with the Earth and can keep the Sun, Earth and Moon all behind them for solar power, while still providing a clear view of deep space for telescopes. The L3 position is on the opposite side of the Sun to the Earth. Because the L3 point is always hidden from the Earth by the Sun, it's become popular in science fiction as the location of a hypothetical second Earth. In this news story, the L4 and L5 positions are important. They provide stable orbits around 30 degrees in front of and 30 degrees behind Earth's orbit around the Sun. It's at these locations where Trojan asteroids are commonly found. Back in 1961, Polish astronomer Kazimierz Kordylewski reported signs of strange dust clouds in what appeared to be semi-stable points about 400,000 kilometers from the Earth. But these clouds are so exceptionally faint their very existence has remained controversial, at least until now. That's because astronomers have now finally confirmed the existence of the clouds at the L4 and L5 positions, describing their observations in the journal Monthly Notices of the Royal Astronomical Society. The study's lead author, Gabor Horvath of Jotland Lovos University, modelled the Kordylewski clouds, as they're called, to assess how they formed and how they might be detected. The researchers were interested in their appearance using polarizing filters, which transmit light with a particular direction of oscillation, similar to those found in different types of sunglasses. Scattered or reflected light's always more or less polarized, depending on the angle of scattering or reflection. The authors then set out to find the dust clouds. Armed with a polarizing filter system attached to a camera lens and a CCD detector, the authors took exposures of the purported location of the Kordylewski cloud at the L5 position. And the images they obtained did show polarized light reflected from dust extending well outside the field of view of the camera lens. The observed pattern matches predictions the team had made earlier, and it's totally consistent with the earliest observations of the Kordylewski clouds taken 6 decades ago. Given their stability, the L4 and L5 positions are seen as potential sites for orbiting space probes and as transfer stations for future missions exploring the wider solar system. Further research will look at L4 and L5 and the associated Kordylewski clouds to understand how stable they really are and whether their dust presents any kind of threat. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
We're going to talk about a dust cloud that's orbiting Earth. I knew that space was a dirty place. Why does it have to hone in on us? I mean, it's filthy enough here already. This dust cloud that's enveloping us and making a mess of our little piece of the solar system. What's this all about?
Well, you're quite right that space is pretty dusty. And actually, we, particularly here well, let me put it this way, particularly for you up in regional New South Wales, where you've got fairly dark skies, you can see that dust every night almost when there's no moon around, because there's something called the zodiacal light, which puzzled astronomers for quite a long time as to what it was. But we now know that this is the light from dust in the solar system. It's something you can see after sunset or before sunrise. It's like a pillar of light that is sort of standing above the sun. I've seen it many times because, of course, Siding Spring is a very dark place, so we don't have much light pollution. But that's living proof, if you like, of the fact that the space between the planets is quite dusty, because that pillar of light is just essentially the sun illuminating the disk of dust that is around it, so the dust in the plane of the Earth's orbit. But this story is about something a little bit different, and it's about the way that dust can congregate, because back in 1961, Polish astronomer whose name was, I think I'm pronouncing this correctly, Kazimierz Kordylewski.
Sounds good.
He basically proposed the notion that there would be clouds of dust in gravitationally stable points in the Earth-Moon system. These are the Lagrange points. And Lagrange was a 19th century mathematician who proposed that there would be, if you've got any two gravitating bodies, for example, the Earth and the Moon, there will be positions around them where their gravity combined with the rotation of the Moon around the Earth, where they would conspire to produce what you might call neutral points where there's no pull of gravity. And the first one of them, the one we call L1, the first Lagrange point, is really easy to get your head around because it's between the Earth and the Moon, and you can intuitively imagine that, if somewhere between the Earth and the Moon there's going to be a point where their respective gravity balances out.
And it wouldn't be halfway unless the gravity of both bodies was equal.
The same. That's correct. Yeah. Absolutely. So it's much nearer the Moon than it is to the Earth, because the Earth has the greater gravitational power. But there are 4 other of these stable points sort of dotted around the space around the Earth and the Moon. And 2 of them in particular are of interest because there's a lot of astronomical phenomena that essentially center on these things, and they rejoice in the name of L4 and L5, the 4th and 5th Lagrange points. They're sometimes called the Trojan Points because they attract asteroids in other contexts. Let me digress briefly to explain that. If you think about the planet Jupiter going around the Sun, 60 degrees ahead of Jupiter in its orbit. So what's that? That's a sixth of the way around its orbit ahead and a sixth of the way around the orbit behind. There are 2 of these stable points, the Lagrange points, and they actually collect asteroids in the case of Jupiter and the Sun. So Jupiter's got this clump of what are called the Trojan asteroids preceding it in its orbit, and another clump of likewise named Trojan asteroids trailing behind it, 60 degrees behind it in its orbit. So that's why they're called the Trojan points.
Right.
Okay, that was a digression. Now think about the Earth and the Moon again. So there are 2 Trojan points, one ahead of the Moon, one behind, a sixth of the way around, as we've said, 60 degrees ahead and behind the Moon. And what Dr. Kordylewski proposed was that those points, because they're stable gravitationally, they would be a place where dust would congregate. Just the dust in the solar system would tend to accumulate there. And he actually believed he had photographic evidence of that. In other words, he took photographs of the space 60 degrees ahead of and 60 degrees behind the Moon and thought he could see a brightening. But it was not terribly convincing. So there the story languished until now, basically, because a group of astronomers, not based actually in Poland, but based in Hungary, scientists there have done a double whammy on this. They've published 2 papers in that august journal, the Monthly Notices of the Royal Astronomical Society. It's actually one of the leading professional astronomy journals in the world. They've got 2 articles in there, one of which basically builds a theoretical model of these dust clouds and says that, yes, the theory does predict, exactly as Kordylewski said, that there would be clouds of dust in these positions relative to the Earth and the Moon. But the second paper is about observations they've made of not both of these, but one of them, I think it's the L5 cloud that they've observed. And it's really interesting observations. So, of course, what you've got to do is choose, first of all, a site where the sky is very dark, so no artificial light. You need to be well away from twilight, so there's no light from the sun in the sky. You need to be well away from moonlight as well. So you want the moon below the horizon. Probably at the time of new moon is the best time to do this. And then you look at the place where you expect to find this dust cloud. So they've done that. They have found a brightening of the sky there. But more especially, they've identified something else that is kind of the smoking gun for a dust cloud.
Let me guess, an intergalactic lounge chair, because there's always dust behind one of those.
It's all about polarization. So we have means of measuring this property of light. So, when you look at things in space, you can measure their color, their brightness, but you can also measure their polarization as well as the spectrum. Of course, that's the distribution of color with, the intensity with color. So you can measure polarization. You use a very specific and rather sensitive piece of equipment called a polarimeter. And a polarimeter is really just a glorified pair of polarizing sunglasses. I know the polarimeter specialists in the world would be reacting with horror at that statement because they couldn't be more different. But the principle is the same. What you're doing with polarization is you're trying to isolate the particular way in which the light waves are vibrating. So what's called unpolarized light, which is kind of what's all around us most of the time, is light that's vibrating in many different planes, an infinity of different planes, really. But if you are wearing polarizing sunglasses, for example, what you then do is just isolate one of these planes of vibration. And the reason why you do that with sunglasses is because the light from a reflecting surface, like a body of liquid or a brightly lit road, is highly polarized. So that allows you to just select one of the ways in which the light vibrates. Now, we know that dust in space actually polarizes light. And so that is one way of detecting when you're actually looking at dust rather than just something else that's brightly illuminated in space. And that's the smoking gun in this case. So these Kordylewski dust clouds, the one that has been observed by these Hungarian astronomers, shows strong evidence of polarization, which tells you that you've got a cloud of dust there rather than a cloud of gas that's just self-illuminated, something of that sort.
So what they've thought was there all along is basically what we've found out through polarization. Just a couple of thoughts, though. How big are we talking in terms of this dust cloud and what's likely to happen to it long term?
So, yeah, that's right. The dust cloud itself is probably bigger than the moon. It's a fairly, what's the word? It's certainly not a dense area of dust. It's reasonably tenuous. There is motion of the dust particles themselves within the cloud, and that, anything that's got this sort of excited motion about it tends to be bigger if it's made of particles. In a sense, what's happening is these individual dust particles are in orbit around the Lagrange point, which sounds a bit weird. How can you be in orbit around nothing? Well, gravity lets you do that. Yeah. But the other thing that these scientists have done is to model the way that this dust cloud is being replenished from the general dust within the inner solar system, and to try and get a measurement of how long it will last. In other words, what its lifetime is. And it looks as though it's a fairly stable feature. It probably will last for many billions of years.
Unless my wife finds out about it and she's up there with her vacuum cleaner, and that's just the way she swings. But,
as I've said before, Andrew, I'm not going there.
But we have an answer in astronomy. At last.
We have an answer in astronomy, that's right.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. The Russian Federal Space Agency Roscosmos will recommence manned space flights to the International Space Station next month. The decision to launch follows detailed investigations into last month's ascent aboard of the Soyuz MS-10 flight from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The emergency on October the 11th occurred as the four strap-on liquid-fueled boosters were being jettisoned a minute and 58 seconds after launch. The boosters are programmed to flip backwards and clear of the core stage in a spectacular maneuver known as a Korolov cross. However, one of the boosters, the D booster, failed to separate cleanly, fatally damaging the Soyuz FG launch vehicle in the process. The Soyuz capsule, which was carrying 2 crew members, was safely jettisoned, landing in a high-G ballistic descent, hitting the ground 5 times before coming to rest on its side 400 kilometers downrange of the launch pad. The failure was traced to a deformed sensor on one of the strap-on boosters, which had been improperly installed during the Soyuz rocket's final assembly. The damaged sensor was unable to open a cover on a reverse thrust nozzle designed to help the booster separate from the core stage. This caused the booster to crash back into the core stage, ripping open the fuel tank and causing an explosion. Moscow has since successfully launched the Soyuz 21B rocket, carrying a 6,000-kilogram Russian Lotos military spy satellite into orbit from the Baikonur Cosmodrome 800 kilometers north of the capital. Another unmanned Soyuz will be launched on November the 16th from Baikonur, carrying a Progress cargo ship loaded with fresh supplies for the space station. That flight had been slated to launch on October the 30th, but was scrubbed because of the October 11th failure. Roscosmos says the Soyuz MS-10 flight, which was slated to launch on December the 20th, carrying 3 crew members to the International Space Station, will now instead fly on December the 3rd. The new MS-11 crew will replace those currently on station, will now return to Earth 7 days behind schedule on December the 20th aboard their own Soyuz MS-9 capsule. That's the same Soyuz MS-09, which vented atmosphere into space from the orbital module while it was docked to the space station. That fault was eventually traced to a hole which had inadvertently been drilled and then covered up in the spacecraft, either while it was being manufactured at the Inertia plant or after it arrived at the Assembly and Integration building at Baikonur. Either way, it's still interesting times for the Russian Space Agency. I'm Stuart Gary. This is SpaceTime. Japan has launched a new spacecraft designed to monitor greenhouse gas emissions. The GOSAT-2 was flown aboard an H-2A rocket from the Tanegashima Space Center 300 kilometers south of Tokyo. The 1,800-kilogram probe will be renamed Ibuki 2 once it's in its correct orbit and operating nominally. The new spacecraft will continue the work of its Ibuki predecessor, which was launched back in 2009. It'll monitor and record long-term details of man-made atmospheric greenhouse gas emissions which are causing climate change. The spacecraft carries a cloud and aerosol imager and thermal and near-infrared spectrometer, allowing scientists to monitor carbon dioxide, methane, ozone, carbon monoxide, and nitrogen dioxide levels. It'll fly in a 613-kilometer high circular sun-synchronous orbit. The research will help scientists predict how the emission of fossil fuel pollutants is accelerating global warming. The mission also carried several smaller satellite payloads, including the 330-kilogram CalifaSat remote sensing satellite for the United Arab Emirates. Also piggybacking on the mission were several small microsatellites and CubeSats. California residents have been treated to a spectacular evening launch with a SpaceX Falcon 9 rocket lighting up the Pacific sunset skies. The mission from Space Launch Complex 4E at the Vandenberg Air Force Base carried the SAOCOM-1A Earth observation satellite for the Argentinian Space Agency.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff. Just cleared the tower.
Station tops nominal. Power and telemetry nominal.
All planetary stations are receiving.
Falcon 9 rocket as it ascends through the atmosphere, carrying the SAOCOM-1A satellite to low Earth orbit.
Vehicle supersonic.
Right now, the vehicle is passing through max Q, which is the point of maximum aerodynamic pressure on the airframe. The vehicle actually throttles itself down for this portion of the flight in order to reduce structural stresses.
Altitude 30 kilometers.
We did have a successful liftoff from the pad at Vandenberg Air Force Base at 7:21 p.m., just as expected. Coming up at T plus 2 minutes and 19 seconds, we're going to have a series of 5 events happening all very, very quickly together. That's going to be main engine cutoff, stage separation, second engine start, boost back burn start, and fairing deploy.
100.
Pico.
And there you have it. We had a successful main engine cutoff and then a good stage separation of that first stage. Second stage, Merlin vacuum engine lighting up right now, heating up and preparing to boost that payload the rest of the way towards its intended orbit.
Stage 1 boost back.
Good fairing deploy.
Fairing separation confirmed.
As its Merlin vacuum engine continues to push that SAOCOM 1A satellite into low Earth orbit.
Stage 1 boost back is shut down.
That second stage will continue burning its Merlin 1 vacuum engine all the way until 10 minutes into flight.
Send trajectory nominal.
The grid fins on the side of the rocket have extended. Puffs of gas coming from the rocket are the reaction control system on that first stage as it maintains its attitude coming back down towards the pad. The boost back burn is now complete from that first stage. The next thing coming up at 5 minutes and 56 seconds will be the start of the entry burn. This entry burn happens just as the first stage hits the thicker regions of the atmosphere, so it can slow itself down and avoid damage to those 9 Merlin engines, which are entering first into the atmosphere. Periodic bursts from those cold gas thrusters on the side of the first stage. The first stage as it heads back towards the LZ-4 at Vandenberg Air Force Base. There it is. That's the start of the entry burn of that Falcon 9 first stage. This burn is only about 30 seconds. Right now, that first stage is mostly empty of fuel, so it's actually pretty light. Doesn't need that much force to slow it down.
Stage 1 entry burn shut down.
And that looks like the shutdown of the entry burn.
Stage 1 FTS is safe.
Following first stage separation and upper stage ignition, the Falcon 9 core state successfully returned to Earth, landing on SpaceX's newly built landing pad known as Landing Zone 4, located just 400 meters from the launch complex.
There it is. That's the start of the landing burn.
Stage 1 landing burn has started.
That Falcon 9 first stage should be approaching the ground just about in 5 seconds.
Stage 1 landing burns deployed. Vandenberg, LZ-4, the Falcon is landed.
And it appears that that Falcon 9 first stage has just stuck the landing at LZ-4 at Vandenberg Air Force Base. This is great news for everyone here at SpaceX. Reminder that this is the first time we've ever landed a rocket first stage back at Vandenberg Air Force Base.
The new landing pad's been constructed on the site of the former Space Launch Complex 4W, from which Titan rockets were previously flown. The 3,000 kilogram SAOCOM 1A is the first of 2 microwave observation satellites being launched for the Argentinian Space Agency into sun-synchronous polar orbits. The second will be launched no earlier than June next year. The spacecraft's equipped with an L-band full polarimetric synthetic aperture radar designed to monitor agriculture, vegetation cover, and urban planning. The flight was the 62nd launch of a Falcon 9 rocket, and SpaceX's 16th flight this year. Meanwhile, a United Launch Alliance Atlas V rocket is blasted into geostationary orbit carrying a new US military communications satellite. The fourth advanced extremely high-frequency satellite lifted off from Space Launch Complex 41 at the Cape Canaveral Air Force Station in Florida shortly after midnight.
Rock report range status.
Range green.
Stable at step 3. ECS reduced for launch. Roger.
5.
Status check.
Go out. Go Centaur.
Go AHF 4.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1. And liftoff of the AEHF-4 mission carried by United Launch Alliance Atlas V rocket for the United States Air Force.
T has gone to closed loop control.
You are hearing the voice of Patrick Moore providing launch vehicle
Now passing 30 seconds into flight. Mach 1, Atlas 5 now supersonic. Now passing 40 seconds into flight. And we're experiencing a telemetry dropout in the Denver data station. At this point in the flight, RD-180 should be throttling back up to 100% thrust, passing through max Q. Now passing 1 minute into flight.
Vehicle continues to operate normally during descent. Back to 100% thrust as expected.
And VOCI data now. Now 1 minute 25 seconds into flight. Atlas V rocket now weighs just 1/2 of what it did at launch, burning propellant at a rate of 6,900 pounds per second. And we have burnout on all 5 SRBs. RD-180 throttling back up to full thrust. 1 minute 45 seconds into flight. 1 minute 50 seconds in. And we have jettison of all 5 solid rocket boosters.
The Atlas launch vehicle flew in its 551 configuration, which is currently the most powerful in the Atlas fleet. It includes a 5-meter payload fairing, 5 strap-on solid rocket boosters assisting the RD-180 main liquid-fueled engine, and a Centaur upper stage equipped with a single RL-10 liquid-fueled engine. A twin-engine version of the Centaur upper stage has been developed. It'll be used with Boeing CST-100 Starliner space station crew transfer vehicle, which is slated to begin flying next year. The 6,168-kilogram payload for this mission is the fourth of 6 new advanced extremely high-frequency communication satellites being built by Lockheed Martin for the United States Air Force Space Command. They're designed to replace the old Milstar telecommunications satellites, providing more secure communications for the armed forces of the United States, Britain, Canada, and the Netherlands. They'll incorporate frequency hopping radio technology, as well as phased array antennas that can adapt their radiation patterns in order to block out potential jamming. The 2 remaining satellites in the new constellation are slated for launch next year. As well as being the 50th United Launch Alliance flight for the US Air Force, the mission was also the company's 8th launch this year, and the 131st successful launch since the company was formed back in December 2006. The United Launch Alliance's next flight will be the classified NROL-71 mission for the National Reconnaissance Office. That'll use the Delta IV Heavy, slated for launch on November the 29th from Space Launch Complex 6 at the Vandenberg Air Force Base in California. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims Earth's oceans have absorbed 60% more heat than previously thought. The findings by scientists from Princeton and the Scripps Institution of Oceanography at the University of California, San Diego show that for each year between 1991 and 2016, the world's oceans absorbed an amount of heat energy that's 150 times the energy humans produce as electricity annually. The findings, reported in the journal Nature, are based on a network of robotic sensors known as Argo, which compiles comprehensive measurements of ocean temperature and salinity across the globe. The data suggests that Earth is far more sensitive to fossil fuel emissions than previously thought. It recommends that emissions of carbon dioxide, the chief greenhouse gas produced by human activities, must be reduced by around 25% compared to what was previously estimated. University of Adelaide researchers have delved into the realm of Star Wars and created a powerful tractor beam, a light-driven energy trap for atoms. In this case, rather than sucking spacecraft into a space station, the tractor beam pulls atoms into a microscopic hole at the center of a special optical fiber. The findings, reported in the journal Physical Review Applied, opens the way for new quantum experiments that may one day lead to secure communications or advanced sensing technologies. A new study shows that the first Australians arrived on the continent by crossing Indonesia and New Guinea when they were both still part of a single landmass between 50 and 70,000 years ago. The findings by researchers from the Australian National University indicate that sea levels back then were between 20 and 50 metres lower than what they are now. The new research, reported in the Journal of Human Evolution, challenges the popular theory that these early adventurers travelled from Southeast Asia through Indonesia and Timor before crossing the sea to reach Australian shores in what is now the Northern Territory. Researchers say the oldest states for human occupation on the Australian New Guinea continent, known as Seoul, represent the earliest indirect evidence for seafaring by humans anywhere in the world. The islands directly north and west of Seoul, which were known as Wallachia, were never connected to the mainland, requiring multiple successful water crossings east from the mainland Southeast Asia, then known as Sunda. These people hopped their way across these islands, probably looking for a place to live where they could have access to reliable food staples and other resources. Scientists say the visibility between the islands would have been very favourable in terms of enabling this sort of adventurous spirit. Iranian military infrastructure involved in illegal nuclear weapons research has come under attack from a new Stuxnet-like computer virus. The original Stuxnet worm was used in 2010 to seriously damage and delay Tehran's secret nuclear weapons program. Stuxnet specifically targets programmable logic controllers, causing fast-spinning centrifuges, which are used to produce weapons-grade uranium, to literally tear themselves apart. The new virus is described as being more violent, advanced, and sophisticated. Details of the new attack came just hours after Israel said its Mossad intelligence agency had thwarted an Iranian murder plot in Denmark, and 2 days after Iran had acknowledged that President Hassan Rouhani's mobile phone had been bugged. In fact, it follows a string of Israeli intelligence coups against Iran, including the extraction from Tehran in January by Mossad of the contents of a vast archive documenting the Islamic Republic's illegal nuclear weapons program, and the detailing at the United Nations of secret Iranian nuclear and missile assets inside Iran, Syria, and in the Lebanon. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favorite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.